Okay, Suhas. Vedant is saying 125 joule. Let us see how much is the answer. Pay attention. So by LMC, by linear momentum conservation. So 10 into 20 plus 5 into 10 is equal to M, that is 10 VA plus 5 VB. Okay, this is by linear momentum conservation. So 10 into 20 will be 200 plus 50, 250. So 250 is equal to 10 VA plus 5 VB. And that gives us 2 VA plus VB is equal to 50. This is equation number 1. This is equation number 1. Okay. So this is by linear momentum conservation. Now next is by E's equation. By E's equation. So E is equal to half is equal to velocity of separation, that will be VB minus VA upon velocity of approach, and that will be 20 minus 10. That will be 20 minus 10. So that gives us VB minus VA is equal to 10 by 2. 10 by 2 is 5. Equation number 2. Okay. Now, if I subtract 2 from 1, so 1 minus 2, that will give us, pay attention, 2 VA plus VB minus VB plus VA. So this will be 3 VA is equal to 50 minus 5 will be 45. So that gives us VA is equal to 15 meter per second and VB is equal to 20 meters per second. Why? Because VB is equal to VA plus 5. VA is already 15. 15 plus 5 will be 20. Now what you need to do is you need to find how much was kinetic energy initially. Then you need to find how much is kinetic energy finally. And then you need to find the difference of two. So kinetic energy initial is equal to half into M is 10 into 20 square plus half into M is 5 into 10 square. Please quickly tell me how much is that. So 20 into 20 becomes 400. 400 into 10 becomes 4000 by 2 is 2000 plus 10 square is 100. 100 into 5 is 500 divided by 2 is 250. So that comes out to be 2250 joule. That is kinetic energy initial. Now comes kinetic energy final is equal to half into M. M is 10 into VA. VA was how much? 15 square plus half into 5 into VB is 20 square. So 15 square is 225. 225 into 10 will be 2250 divided by 2. So that will be 1125 plus 20 square will be 400. 400 into 5 will be 2000. 2000 by 2 will be 1000. So 2125. This is final kinetic energy. So delta K is equal to Ke final minus Ke initial is equal to 2125 minus 2250, and that comes out to be minus 125 joule. So this much will be the loss of energy. Vedant, you were right. You were right, Vedant. Hmm. Okay. So this much will be the loss of energy. Any doubt, any question? Any doubt, any question? Good, good. Next question on your computer screen. Pay attention. Question. This is a wall. This is a heavy wall. Heavy wall. Okay. And this is moving with velocity of 15 meters per second. This is a ball and this is of mass 5 kg and it is moving with 10 meter per second. Question says if collision between wall and ball is perfectly elastic, find velocity of ball. Find velocity of ball after collision. So you need to find velocity of ball after collision. Please find. Please find. Suhas is saying 40, Samarth is saying 40. Okay, everyone please pay attention. Please pay attention. To solve this question, you have to use a little bit of common sense also. So suppose this is the ball after collision. Okay, so V is, let's say the velocity. Let's say the velocity is V. Okay. Now suppose my question to you is, you are going on road on a cycle. Okay, you can take a bike also, and there is a road roller going on road. Okay. If you go and collide with the road roller, please don't do that. If you go and collide with the road roller, what will be the effect on speed of road roller? Will there be any change in speed of road roller if you collide with that? No, there won't be any change unless you are Rajnikant. Okay, there won't be any change in speed of road roller, right? Okay, now comes the next question. If this ball is colliding with the wall, which is a heavy wall, will there be any change in speed of wall? No, there won't be any change in speed of wall after collision, right? Good. So what we can do, we can apply E's equation. So by E's equation, so E is equal to 1 because collision is perfectly elastic, is equal to velocity of separation V minus 15 upon velocity of approach. How much is velocity of approach? So that is 10 minus 15, right? So that gives us V minus 15 is equal to 25 and V comes out to be 40 meters per second. V comes out to be 40 meters per second. Please note. So 40 is the answer. 40 is the answer. Please note. 40 is the answer. Okay. Now, I'm giving you a formula also. You can also create that formula. Suppose this was velocity V. Okay. I'm calling this as V final. And the ball was coming with velocity U. Ball was coming with U. Okay. And in this case, what will be the answer? Let us pay attention. Someone's mic is unmuted. Please mute it. So E is equal to 1 is equal to velocity will be V final minus V upon U minus V. Okay. So that gives us V final is equal to 2V plus U. Okay. Remember that U is velocity of ball and V is velocity of wall. Okay. Okay. But this is applicable only for perfectly elastic collision. If collision is not perfectly elastic, then you have to put value of E as per the equation and then you can get the answer. Okay. Okay, everyone. Good. Next question on your computer screen. Question. This is ground. This is ground and this is a ball. This ball is released from height h. Mass of ball is m and the collision has coefficient of E. So if ball is released from height h, if ball is released from height h, find the height up to which ball will rise after colliding with ground. After colliding with ground. Okay. So please find. Samarth is saying E square H. Okay. Everyone, please pay attention. Gauri is also saying E square H. Okay. Everyone, please pay attention. Suppose the ball has velocity of u before collision and v after collision. Okay. So by E's equation, so E is equal to velocity of separation. Velocity of separation upon velocity of approach. So E is equal to V. Now velocity of ground will remain 0 because ground is at rest, right? So velocity of separation will be V minus 0 because only ball is going away. Ground is not going with the ball. Ground remains stationary. Correct? Good. Now velocity of approach, that was u minus 0 because only ball was coming to ground. Ground was not going to ball. Okay. Basically what we are saying is that ground will remain stationary or unmoved. Ground will remain unmoved. Okay. So this gives us V is equal to EU. This gives us V is equal to EU. So if V is the velocity with which you are projecting anything vertically upward, so H max in that case, H max will be V square upon 2G, and that will give us H max will be V square means E square U square upon 2G. That will be E square U square upon 2G. Okay. Now, the only question which is left for us is how much is the value of U? How much is the value of U? So, U is nothing but under the root of 2GH. Let us put that. When we are going to put that, we are going to get H max is equal to E square under the root of 2GH whole square upon 2G, and that will be E square H. This is the answer today. This is the answer today. So Pooja has given the correct answer. Suhas also, Asmita also, Gauri also, Samarth also. I don't know where are the rest of people. Chrisley, you did not give any answer. No, Shane. Where is your answer? Where is your answer? That's so bad. All of you should give answers. Right or wrong is
immaterial. रास्ते में है सर. नौशेन फास्ट चला करो भैया. You need to move fast. Okay? You need to move fast. Life is a race. There was some dialogue from some movie. Can we move further? Can we move further? Good. So this all was head-on collision. What if the collision is not head-on? That means if it is oblique collision, then what will be the scenario? Yeah, Vedant. So oblique collision. Oblique collision. So what was happening so far or in head-on collision, that objects were moving on a straight line. Objects were moving on a straight line. Correct? But Vedant, one more important thing. You should never follow these people who are in Bollywood. Why so? Because the same person who was trying to tell that one should follow excellence and not marks is nowadays selling Vedantu. Correct? Yes or no? Same person. So इनको आप पैसा दो, कुछ भी बोलते हैं लोग, कुछ भी बोलते हैं. All Bollywood people, all, no exception. Okay, so let us get back to the topic. Oblique collision. So what is oblique collision? If the colliding objects do not remain along a straight line before and after collision. Okay, if colliding objects do not remain on a straight line or along a straight line, along a straight line before and after collision, before and after collision, then such collisions are called oblique collision. Such collisions are called oblique collision. Okay, such collisions are called oblique collision. So far in all collisions which we studied, objects were remaining in a straight line. Objects were remaining in a straight line so far. But now we are going to study collisions in which objects will not remain along a straight line before and after collision. So suppose this is one object, A, mass will be obviously ma, and there will be velocity ua. Okay, there is another object B, there is another object P, UB, MB. Okay, now this was before collision. After collision, what is happening? Let's say B is moving in this direction, A is moving in this direction. Okay, so that's what is happening. So this velocity will be VA, this velocity will be VB. So we can draw a straight line like this. Okay, and they are going in this direction. This angle can be taken as beta. This angle can be taken as alpha, right? Okay. Now point to be noted. Our linear momentum conservations are still applicable. Linear momentum conservation is still applicable. So applying LMC along, now I am considering this direction as x and this direction as y. Applying LMC along x-axis. So MAUA plus MBUB is equal to, now pay attention, how much will be the component of VB along x-axis? So this will be VB cos beta, this will be VB sin beta. Similarly, this will be VA cos alpha, this will be VA sin alpha. Okay, so now we can write MAUA plus MBUB is equal to MAVA cos alpha plus MBVB cos beta. This is equation number 1. This is equation number 1. So this is by linear momentum conservation. This is by linear momentum conservation along x-axis. Now along y-axis. Along y-axis. So what we can write is 0 because A has no initial momentum along x-axis, plus 0 because B also have no initial momentum along y-axis, sorry, is equal to MB VB sin beta minus MA VA sin alpha. Let me call this as equation 2. So that way you can apply linear momentum conservations to find answers. To find answers. Okay. You can apply LMC to find answers. Okay. Please note. Please note. Please note everyone. All right. Now let us solve some questions. Question. This is B. mass is, let's say, 10 kg. This is A. Mass is again, let's say, 10 kg. B is at rest. A is moving with 20 meters per second. Okay. Now, after collision, it is seen that B is going in this direction, and this angle is 53 degree. Velocity is, let's say, 10 meters per second. This is A. So what you need to do is, this angle is theta and velocity is VA. Find number 1 VA, number 2 theta. Please find, everyone. So you need to find the theta as well as velocity of A after collision. Answer, everyone. Okay, everyone, please pay attention. So along this direction, this will be 10 cos 53. This will be 10 sin 53. Similarly, this will be VA cos theta. This will be VA sin theta. Okay. By LMC along x-axis. So tan into 20 plus tan into 0 is equal to tan into 10 cos 53 plus tan into VA cos theta. So you must have noticed that by taking masses as same, we are simplifying the calculations very quickly. So 20 is equal to 10 cos 53 is tan into 3 by 5, which is 6 plus VA cos theta. So VA cos theta came out to be 20 minus 6 is 14. Equation number 1. Along y-axis. Along y-axis. So 0 plus 0 is equal to m, which is 10 into 10 sine 53 minus 10 into VA sine theta. So what we can notice is 10 got cancelled. VA sine theta is equal to 10 sine 53, that is 8. I hope calculation is correct. So squaring and adding. Squaring and adding 1 and 2. So VA square sine square theta plus cos square theta is equal to 14 square is 196 plus 8 square is 64. 196 plus 64. So that came out to be root of 260. That came out to be, that is actually VA. And let me take root. So VA came out to be root of 260. All right. This is the answer. This is the answer. Now, if you want to know theta also, divide. So 2 by 1. So 2 by 1 will be tan theta is equal to 8 by 14. So theta is equal to tan inverse 4 by 7. How many of you solved all parts correctly? How many of you solved all parts correctly? All parts means all parts. Okay, next question. Next question. I hope you all have noted. And this question says, this is ground. This is a ball. and this is M. Okay. This is ground with E. Okay. This angle is given as theta. All right. Question says find velocity of ball. Ground is smooth. Ground is smooth, so you don't need to worry about friction. Find velocity of ball. Find velocity of ball after collision. Find velocity of ball after collision. Do you want to try this question? Try for 2 minutes. Okay, everyone, please pay attention. If this angle is theta, this will also be theta, right? So if this was coming with velocity u, this velocity will be u cos theta, and this velocity will be u sin theta. Okay. Now listen carefully, everyone. Keep everything aside and listen carefully what I am telling you. Okay. The ball has two velocities. One velocity is u sin theta and one velocity is u cos theta. Okay. Okay. When the ball is going to be in contact with ground, or in other words, you can say when ball is going to collide with ground, ground is going to exert force on the ball, right? That force will be normal reaction. That force will be normal reaction, and that will be perpendicular to the surface. That will be perpendicular to the surface. As the ground is smooth, as the ground is smooth, it cannot exert any force along the surface. As the ground is smooth, I am writing these words. As the ground is smooth, it cannot exert any force along surface. Okay, and along surface can be only one force, friction, which is 0. Okay, friction is 0, right? So the point which is to be noted is, if there is no horizontal force acting on the ball, its horizontal velocity will remain unchanged. Its horizontal velocity will remain unchanged, or you can say x direction velocity will remain unchanged. Remember this point in your mind. Okay, as there is no force acting on ball along horizontal, as there is no force acting on ball along horizontal, its horizontal velocity, basically x direction velocity, okay, will remain unchanged. Will remain unchanged. Any doubt, any question? Good. So Vx is equal to Ux is equal to U sine theta. This is the point to be noted. Vx is equal to Ux is equal to U sine theta. Now comes the next question. Okay, that the ball is actually coming with U cos theta towards the ground. Okay, after collision, I am considering that this is the scenario. This, okay, this velocity is U sine theta. We have realized how much will be velocity in y direction. That we need to find out. Right? Okay, now as normal reaction or force is acting on the ball only along y direction, its velocity will change only along y direction, right? Okay, and E is also given to us. That means we need to use E also. That means, listen very carefully what I am saying. That means E can be used only along y direction. Why? Because along x there is no change. Along x there is no change. So E can be used only along y direction. So let us use that. So E is equal to velocity of separation upon velocity of approach. So E will be, velocity of separation will be Vy, and velocity of approach was U cos theta. So Vy comes out to be EU cos theta. Vy comes out to be EU cos theta. Okay, everyone, please note this. Please note this. So now if somebody asks you what will be the final total velocity of ball, can you find that? Yes, you can do that, because you have Vx, you have Vy, so you can find the final net velocity also if somebody asks you that. Correct? Okay. One more thing which I want to tell you. See, in this question, this was an oblique collision. Right? We did not know in which direction we should apply E's equation. In this question, we did not know in which direction we should apply E's equation. But when we used basics of physics, we got to know that we should apply E's equation along y direction, or along the direction in which normal force is acting, or you can say along the direction in which forces are acting during collision, right? So this is a very important point. E's equation is applied along the line of impact. This is very important. E's equation is applied along the line of impact. Okay, so we apply E's equation along the line of impact. Okay, now you may ask, sir, what is this new term, line of impact? Basically, line of impact is the line along which impulsive forces act during collision. Okay, so line of impact is the line along which impulsive forces act during collision. Impulsive forces act during collision. Okay, please note this, and I'm getting back to the diagram once again to explain a little bit more things. Okay, pay attention. Now visualize this whole thing, that the ball which had speed u, okay, I'm talking in terms of speed u. So ball was coming towards ground with speed u, as you can see, right? Okay, now visualize what I'm going to tell you. What we did, we resolved this velocity u into two components. One is u cos theta, one is u sin theta. Okay, listen very carefully. Now u sin theta is parallel to the ground. U cos theta is perpendicular to the ground. Okay, so as the ground is smooth, it cannot exert any force along it. Why? Because friction is the only force which can act along the ground, and ground is smooth, so it cannot exert friction. So u sin theta will remain unchanged, and it remained unchanged. You can see here, u sin theta remained as u sin theta. What changed? U cos theta. The ball was coming towards ground with u cos theta. The ball was coming towards ground with u cos theta, but it went away with eu sin theta. It went away with eu sin theta, because that was the velocity of separation. That was the velocity of separation. Okay, so only thing that changed was velocity of separation. And why did it change? Because of E. Because of E. Any doubt, any question, anyone? Good. Good. Question. This is a ball of mass m. Ground is smooth. Collision coefficient is E. Okay. If this angle is theta, so this will be colliding with the ground, and after colliding it will go like this. Okay. So for ball, find number 1 T, number 2
H max and number 3 are after collision. After collision. Okay, you need to find these three answers. Samarth is saying, suppose E is 0, then what will be the case? Okay, Samarth, pay attention. Pay attention. It's a good question. This is ground. This is ground. Okay. And this is the ball which was coming, right? This velocity in last question I am talking was u cos theta, and this was u sin theta. Now, when the ball collided with the ground, okay, nobody can change u sin theta, so it will remain u sin theta. But Vy, it became 0. Why? Because E is 0. No, it will not stick to ground. Listen carefully what is happening. So Vy is becoming 0. But u sin theta is still there. So ball will become beamer. This situation is called beamer. When the ball is hitting the ground and then it is not bouncing up, it is going sliding and hitting the wickets. Such balls are called beamers. Okay. Okay. And these are considered real ball. Umpire doesn't say that it is dead ball or something. It is called beamer. No, it is not dead ball. Dead ball is when ball is making more than 2 tips. It is called beamer. Ball is hitting the ground and then going and hitting stumps. Okay. Usually bowlers are not able to bowl this way because how you are going to make sure that E is 0? Okay. Rarely this thing happens. What is that different definition in Suhas? Throw some light. I think it is called beamer. If my memory related to cricket is working well. No, that is different. That is full toss. That is full toss. Are you sure, Suhas? Okay, let's not get into cricket territory. Okay, let's not get into cricket. But what I explained is absolutely correct. The word for such kind of balls will be different. Okay, Suhas is a cricketer. Very nice, Suhas. You have played up to which level, Suhas? Then find out the term used for this. School district. Now, Shane, he is not talking about you, gully cricket. Find out what these balls are called. I think there is a special name for such kind of balls. Okay. Focus on the question. The thing which I explained according to physics is absolutely correct. Okay. The word beamer according to cricket could be different. I have stopped watching playing cricket for last more than 10 years. Okay. So don't blame me for that. In fact, more than that. 15, 16 years. Even more than that. Okay. So Vy will become 0 and ball will go with u sin theta. Solve the question which I have given.
Asmita is saying 2u sine theta by g. H max is u square cos square theta upon 2g. R is equal to e u square sine 2 theta by g. Okay, everyone, please pay attention. Please pay attention. So this time this velocity is u. So this will be u sine theta and this will be u cos theta. So after collision, listen carefully. This component will be u cos theta as it is. This component will be eu sine theta. Eu sine theta. Okay. So T will be 2uy by g. Uy is eu sine theta. So 2 into eu sine theta by g. In your answer, E is not there, Asmita. Number one. Number two, H max. So H max will be u square, basically uy square upon 2g. So again, E square u square sine square theta upon 2g. Number three, R is equal to 2ux into uy by g. So 2 into ux, u cos theta, into uy, eu sine theta by g. So E is E, U into U is U square, 2 sine theta cos theta is sine 2 theta by G. So that is R. That is R. This is R. There are 3 people who have liked Asmita's answer. Very nice. That's what democracy is doing in India. People are getting, crowd for anything what they are doing. Whether it is right or wrong, immaterial. Okay. That is the good thing or bad thing of having lots of people. You are followers for everything. You have followers for everything, whether good or bad, right or wrong. Correct? Asmita understood the answer. No, I don't like at all communism. And don't try to divert this class from physics to political science. Okay. Explain R. The formula for R is 2 into ux into uy by g. I taught this long back. So R is equal to 2 into, this is into basically, this x is into. Okay. So 2 into u cos theta into eu sin theta by g. Okay. Good. Good. Next question. A ball, or let's not blame ball, a bomb of mass m is lying on a smooth table. If it explodes into two pieces, of mass ratio 1:2, and heavier mass moves with 10 meter per second. Find speed of lighter mass. Find speed of lighter mass. Find speed of lighter mass. Please find. Okay. Okay. Nowadays, Rohan is not answering questions. Rohan, Rohan, not Rohan, Ronald. Ronald, are you there? This is a mass M, okay, and it's a bomb. Stay away from it. Now, due to explosion, it splits into two parts. It splits into two parts, and mass ratio are 1:2. So, if one is m by 3, another will be 2m by 3, okay. And the heavier mass, which is 2m by 3, it is moving with 10 meters per second. So simple LMC will be able to help you. By LMC, by linear momentum conservation. So m by 3 into 0, or you can say, first of all, P initial is equal to P final. This is final. P initial is equal to P final. How much is P initial? M into 0 is, is equal to V final. M by 3 into V plus 2m by 3 into 10. Barabar. And that gives us V is equal to minus 20 meter per second. Now minus sign is simply indicating that velocity will be opposite to the direction of movement of heavier mass. Only that. But in question we were supposed to find speed. So answer is 20 plus 20. So speed will be plus 20 meters per second. Speed will be plus 20 meters per second. All right. Good that all of you have given the correct answer. Next question. A bomb of mass m is lying on a table, smooth you can say. And don't ask me that, sir, what happened to the table after blast. Okay, table remains there. It is made up of anti-blast material or blast resistant material, whatever. So a bomb of mass m is lying on a smooth table. Due to explosion, it breaks into three identical parts. If two parts, if two parts go mutually perpendicular, cular, if two parts go in mutually perpendicular direction with speed 20 meters per second each, find speed of third part. Find speed of third part. Please find. Okay, everyone, please pay attention. So this was the bomb. Okay, this. Now it got broken into three parts. One, two. So this is one part, this is two part, and this is third part. Okay. Now listen carefully. One part is going in this direction. One part is going in this direction. 20 meter per second. 20 meter per second. This part we don't know where it is going. We are considering it as V. Okay. Now P initial is equal to 0. Initial momentum is 0. We are considering this as x-axis, this as y-axis. So P final vector will be m by 3 into 20 m by 3 into 20 I cap plus m by 3 into 20 j cap plus m by 3 into v vector. This is P final. So by LMC, so P initial vector is equal to P final vector. So 0 is equal to m by 3 into 20 I cap plus m by 3 into 20 j cap plus m by 3 into v vector. So this is m by 3, m by 3, m by 3. So v vector comes out to be minus 20 I cap, minus can be taken out, plus 20 j cap. So magnitude of v vector, which will be speed, will be under the root of 20 square plus 20 square, and that comes out to 20 root 2 meters per second. That will be 20 root 2 meter per second. Any doubt, any question? Okay. Next question. IPQ means in the previous question. If one particle or one part goes with 30 meter per second and another goes with 40 meter per second, find speed of third particle part basically. Find speed of third part. Please find quickly. Suhas is saying, what if angle is asked? You answer that, Suhas, because if it is asked to you. Okay, Suhas? Okay. Okay, everyone, please pay attention. So in this question, most of you have done it correctly. P initial was 0. P final is equal to m by 3 into 30 I cap plus m by 3 into 40 j cap plus m by 3 into v vector. So v vector comes out to be minus is out 30 I cap plus 40 j cap. Okay. So v will be under the root of 30 square plus 40 square, and that will be 50 meters per second. Okay. So Suhas, by now you would have realized that if he wants to ask question related to angle, then angle can also be calculated. Tan theta is equal to perpendicular upon base. Okay. But for that you have to specifically need to give that, okay, how much is angle for which velocity, or which velocity is in which direction. Okay, that is very easy, not a big deal in that. Okay, understood everyone? All right, so that is enough for today. We'll be studying further in next class, and most likely we'll be starting a new chapter. Okay, thank you so much.
Sir, but power is yet to be done, no?
Yeah, power is to be done. First we'll finish power and then, okay. Okay, Mayank.